Okay, before we get to the actual notes for 6.6, we want to look at the two parent functions for parabolas, quadratics, the real basic graphs. One is y equals x squared. The other is y equals the opposite of x squared or negative x squared. These are the tables for these two graphs. Whether you square a negative or a positive on y equals x squared, you're going to end up with positives in the y column. When you have the opposite of x squared, you plug them in, you square it, they actually turn back negative except for 0. But if we were actually going to graph these, so if I actually took this table and I hit graph, so we'll go down here to math actions and we will say generate graph. There's what it looks like. You've got the general basic shape of a parabola that opens up. Let's look at the one with negative x squared. If I actually said, let's look at this one, and I said math actions, let's generate a graph. Now you can see negative, it's flipped upside down. It's negative x squared. And I didn't actually connect the parabola, but you can see where the points are plotted. Okay? What we're going to get into in this lesson is something called vertex form. We're going to be moving, as you can see, the vertex of those two are at the origin. In vertex form, which is this right here, y equals, and I'll get much more into detail with what everything means here, but you have something out in front of parentheses called the a value, and then inside x minus h, and that could end up being a positive or a negative inside there, with a square outside that binomial, and then plus some number outside k. The vertex is actually going to be at those two values, h and k. The vertex shifts from the origin, like y equals x squared and negative x squared, both horizontally and vertically. If you have a number inside with the x, inside what you're squaring, the binomial, and number outside, it's going to shift both horizontally and vertically from the origin. Changing the a value, or what's in front of parentheses, or in front of the binomial squared, all that does is make the parabola narrower or skinnier. Okay, narrower is going to be when it's closer to 0, or fractions, and skinnier is going to be when it's farther from 0, either bigger positives or smaller, real small negatives. So if we actually get into the lesson itself, you didn't have to write anything down, I just wanted to talk about how they're related to those two basic graphs that hopefully you're pretty familiar with. So now we'll get into actually the title of the lesson, which is Analyzing Graphs of Quadratic Functions. Graphing a quadratic function in vertex form. Again, this is vertex form. I just talked a little bit about that. Vertex form is right here. And the vertex is at hk. The axis of symmetry is x equals some number, and it's going to actually be at what that value is inside there that we're either adding or subtracting from x. Okay? And we'll get into the details on that. If the a is bigger than 0, so it's positive, it opens up. If the a is less than 0, the parabola is going to open down. Very similar to when we looked at them in expanded form, where they were in ax squared plus bx plus c form. Okay, so they're asking us to graph a quadratic in vertex form. So this right here is in vertex form, and they're saying analyze and graph. So I've got some steps listed down here, and we need to fill in some things. So the first thing we're going to fill in is the vertex. If you think about this, y equals a times x minus h squared plus k. The vertex is at hk. That means I take the opposite of the sign. If you see there's a minus 3 right here, okay, that means the vertex is at 3. So the vertex would be, the x value of the vertex would be at 3. And the k would be this number, would be 2. So in effect, when you're doing your h and k, and we'll get into some more examples here, you're taking the opposite sign of what's inside with the x, inside the binomial squared. The y value, or the k, is the same sign that's out here after the parentheses. So there's the vertex, 3, 2. The axis of symmetry is going to be x equals whatever this value is right here. So it's at x equals 3. If we're going to graph this, let's write down some more information here. This actually, because now there is nothing out in front of the parentheses, so that actually means that A would equal 1. If there's no number out in front, A is equal to 1. So that is the same shape as y equals, and it's a positive one, so positive x squared, those two graphs I just looked at. Shifted or translated, 3 units right, 2 up from the origin, because y equals x squared, vertex was at the origin. So if I actually think of it that way, it's translated. Another name for translated is shifted. Okay? So if we're going to graph this, plot the vertex. So we've actually moved from the origin, okay, to 3, 2. So 3 to the right, 2 up. That is my vertex. Okay, we're going to draw the axis of symmetry. The axis of symmetry is at x equals 3. Remember, it's got to be in place of the vertex. So if I actually grab a line here and draw in, I'm going to draw in a dashed line. So there's my axis of symmetry, right in the middle of the parabola. Find 2 points on one side of the axis. I'm not going to do a whole xy table. What I'm going to do is I'm just going to do a couple values here. So 3 is the middle of our parabola, or an x value of 3. That's where our vertex is. So let's do a couple x values to the left of 3. So I'm going to do 1 and 2. If I actually put 1 in there, so if I go back up here, and I put 1 in for x. I put a 1 right in there. I would have y equals, I'm going to do the work up here, 1 minus 3 inside parentheses squared plus 2. Well, 1 minus 3 is negative 2. Square that and add 2. If I square negative 2, I get 4. And I add 2, I get 6. So when I put in 1, my y value outputted a 6. If I put in 2, I don't have tons of room here, but I'll do it over here. I go y equals 2 minus 3 squared plus 2. That would be negative 1 inside parentheses. Got to do 2 minus 3. Square it, add 2. So that's 1 plus 2, which is 3. So let's plot those 2 points. So I'm going to plot 1, 6. So 1, 2, 3, 4, 5, 6, which is going to be right there. And I'm going to plot 2, 3. Now, all you have to really do if you think about a parabola being symmetrical is, and this is what I say right here, is just imagine folding that on the axis of symmetry, that this point would have to be on there because it's symmetric to this point right here. These two would be symmetric to each other. And this is 2 units to the left of the line of symmetry, this point right here. So I'm going to plot 2 units to the right, which would be symmetric. And then you draw your parabola. So there's what that looks like. So you're just getting a kind of seeing what the shift of the vertex has been, finding a couple on one side, reflecting them onto the other side across the line of reflection or axis of symmetry, and then drawing your parabola. So this basically, because A is 1, has the same width as y equals x squared, same width of the parabola. When we start changing that A value is when it makes it skinnier or wider. Okay, now we're going to write, so that's one that was already in that form. Now we're going to look at getting them into that form so eventually we can graph them. We're not going to be asked to graph this one, but if you look here, we're going to take one that's in we're going to take one that's in x squared plus bx plus c form, and we're going to write it in vertex form, which is this right here. So we're going to get it as a number in front of parentheses times a binomial, x plus or minus something inside parentheses with a square on the outside, and then we're going to have a number after it, if there is a number. If not, it sometimes ends up being 0. So here's some steps that you need to write down. Stop if you need to write these down. I'll talk about them here, or pause the video. Group the x squared and the x terms with parentheses. So let's do that first. So here's what I have. Y equals x squared plus 2x plus 4. So what you want to do is I want to group the x squared and the 2x there, and I want to do plus 4 out there. Now I left a space in there for a reason, because we're going to complete the square. Step 2 says complete the square inside parentheses. If you remember in 6.4 we did a whole bunch of stuff with completing the square. So we're going to complete the square inside parentheses. So I take half of this value. So I take half of 2. Now this is a nice one, it's even. Half of 2 is 1. I take that number and I square it. Well, that will be 1. So that gets added right in here, because we're making it a perfect square trinomial that we can write as a binomial squared. Now, if I'm really adding 1 to that side, and listen carefully to what I'm saying here, I've changed that side, the right side, by 1. So normally I would have to add 1. Let's undo that. Let's do it in a different color. Normally I would have to add 1 to the other side. But I don't want to really do that. I want to keep just the y over there. So if I got rid of that plus 1 on this side, I would subtract 1. So I'm actually outside parentheses going to subtract 1. Okay, you'd be adding 1 to the other side, but that really is subtracting 1 outside parentheses. I know that sounds weird, you haven't really done anything like that, but hopefully you see why. If I had a plus 1 over here with the y, I'd have to subtract it to bring it to the other side. Now you're going to write this trinomial right here as a binomial squared, meaning here's what we have. Remember what goes in here? Whatever I squared to get this, so this value right here, it's a positive 1 goes in there. These two right here get combined, and so I have positive 4 and a negative 1 combined is 3. So here's what I'm looking at. This is now in vertex form. So we wrote the trinomial as a perfect square binomial and analyze and graph. So if we wanted to graph this, and we're not actually graphing this one because I didn't give you a graph, A would be 1. There'd be a 1 out in front. So this is going to have the same width as y equals x squared. The vertex would be at, take the opposite of this, which is negative 1, same sign as what's out here. So the vertex would be at negative 1, 3. So negative 1, 3. The axis of symmetry, once you find this, it's whatever this value is, so it's at x equals negative 1. So it's taken that y equals x squared graph and shifted it 1 unit to the left and 3 units up. The axis of symmetry is negative 1. So it's let's write down same shape. So this is, when we're analyzing, we're kind of looking at same shape as y equals x squared, opens up. When I say same shape, I mean same width. Opens up, translated 1 unit left. So 1 unit left and 3 up from the origin. Okay, we're not going to get into actually graphing this one, but that's how you would do it and get things in vertex form. So it involves completing the square. Now we'll get into a little bit trickier one, when there's something other than a 1 in front of x squared. So if you look right here, now we're dealing with that one. When a is not equal to 1, and it gets a little trickier, so please listen very carefully, replay this a few times if you need to. You're still going to group your x squared and x terms together, so here's what we're going to do. Negative 2x squared, whoops, it's minus 4x, so let me change that, sorry about that. So minus 4x, we're going to group those two together, and then plus 2. Now, notice what I say. I grouped the x squared and x's, so I've done that. Factor out the coefficient on x squared. Because we don't have a 1 in front of x squared, here's what we need to do. We need to take this negative 2 and factor it out of what's inside parentheses. So that would be x squared left, and if I take negative 2 out of this term, it's going to be positive 2x. Because negative 2 times 2x is negative 4x. And I still have this plus 2 out there. So group them together, factor out. Whatever that number is in front of x squared, it's got to get factored out of the x squared and the x term. Now, complete the square. Whoops, complete the square inside parentheses. Undo outside parentheses, think distributive property. Here's what I mean by that. So we're going to complete the square. I'm going to take half of 2. Half of the b value, which is 1, and I'm going to square it, which is 1. So I'm going to add 1 here so that we can write this as x plus 1 squared, or a binomial squared. And I still have this negative 2 right here. Now here's where you really got to listen. When I say undo outside parentheses, think distributive property. If I actually distributed this back through to the term I added right here inside, I would get a negative 2 if I distributed this over to that term. So I've actually changed that by negative 2 if I went back and got rid of my parentheses. So we had this plus 2, this one carried down. So I need to think of when I multiply this number times this number, that's negative 2. So I'd actually have to be minusing 2 over on the side with y, but I want to actually do the opposite out there. So I want to add this 2 right there because of multiplying this value times this value is negative 2. Do the opposite outside with whatever number. Now this is just a coincidence that we have a 2 there originally from this one right here, and we add 2. These two numbers are not always going to be the same. Okay, that's just coincidence on this problem. So here's what I have. Y equals negative 2 times x plus 1 squared, and then I'm going to put these two together, which is plus 4. I have now gotten this in vertex form. That is vertex form. So let's do some analyzing and graphing here. So a is equal to negative 2. That tells me it opens down. And it's narrower than y equals negative x squared. It's skinnier. Now when I say narrower, skinnier. The axis, let's do the vertex. The vertex, I take the opposite of this sign. So the vertex would be negative 1. Same sign as this number, negative 1, 4. So it's been moved left 1, up 4. And the axis of symmetry equation is x equals negative 1. That will always match this value. So if we start graphing this, let's go through and do this. Negative 1, 4. My axis of symmetry, so let's graph negative 1, 1, 2, 3, 4. We're right there. Axis of symmetry, I'll just draw this one in. We'll be right there. Okay, now I want to get a couple points to the left of that. And I'm actually going to stop the video because I'm running out of time here, and I'll continue on in part 2.